how heavy is a car with a person in it? 1 tonne? That's quite a heavy car. 1.5 tonne, okay. A 1.5 tonne car, including driver. Is accelerated from rest to 100 kilometres per hour in 8 seconds. What average force is exerted on the car? And we're going to ignore friction at this stage. Yep, we'll get to put friction in it sometime in the future, but at the moment, a lot of physics starts off this way. You just do something simple that you can handle, and then you try and figure out how it changes when you add something like friction into it. So at the moment, we're going to ignore friction. Yep. Okay, any takers for how we're going to start doing this thing? Okay, cool. So let's get the units sorted out for a start. So the 1.5 tonnes per kg, so how many kilograms is that? Okay, so 1,500 kilograms. Awesome. Definitely want to get that sorted out. Okay, so the kilometres per hour is also a bit of drama. So 100 kilometres per hour, what's that in metres per second? 27.8 or something, is it? We've seen that a few times before. Sounds right, 27.777, yep, 27.8 metres per second, good, great start. What are we going to do next? Okay, so you want to use F equals ma because I told you we're going to use that formula. Okay, so, which makes sense because the question's a force question. Okay, so does that help me? Yep, we're going to have to definitely use the 8 seconds somewhere, but there's no time in this formula, is there? So where do we go? Just plug it in. Okay, so what's M? So I'm plugging away. M is, yeah, good. Now what am I going to plug in for A? Good point. I thought it was a good point. Cool. So what am I going to plug in for A? Got to find A. Okay, so how am I going to find A? Changing time, changing distance over changing time? That one? I mean, let's just use our formula from changing velocity over changing time. Okay, so you want to use acceleration is change in velocity over change in time. Yep, okay, I'm going to work with that. So it's gone 27.8 and the time was 8 seconds, which equals some frantic button pushing going. 3.475 meters per second squared. So we've now got a number, 3.475, which gives us an answer of 5212.5 units. Newtons, thank you. Okay, so 5.2 kilonewtons. Okay, so we did have to use our equations of motion. Could have used any of those equations of motion that we done last time to work out what the acceleration is. And once we've got the acceleration, then we can work out force. We're using force as mass times acceleration. Okay, so it's just another formula that we can add to our collection of formula. That's a pretty typical sort of question. You may get a question that goes the other way that says something about so much force is available. What's the acceleration going to be? Rearrange, get the acceleration, and then you can answer questions based on that acceleration.